we go. It's starting to record. And sometimes I help
take everything else down.
Now also, when I'm doing this, also make sure that this screen is recording, because I'm plugging in a USB microphone to the system. And sometimes it doesn't pick up the USB microphone automatically. It picks up the internal audio, the mic jack, which doesn't work because nothing is plugging into it. So I'm just going to put this over here. If you guys speak up, when you ask questions, the microphone can actually pick up your question as well, which helps. One thing that is really distracting is the door opening and closing. If you guys have heard or watched the recording from Tuesday, some of you will probably realize the door opening and closing is really loud. I mean, the pop sound, this microphone picks it up, really well. The thing is, when we're in the class, it doesn't bother us as much because visually we can see the door opening. So mentally, we are prepared for the sound of the door closing. When it is only a screen recording and you cannot see the door opening or closing, then that sound becomes more startling and it's actually more disruptive when you're watching the video. All right. So with that out of the way, we can get started with the class. And I just looked through the this activity here, and about 32 people did it as of 10 o'clock. So I think maybe about, I would say about 30% of the class forgot about it. So I'll give you another chance to do it instead of dropping people right away. But this class is still very full. I cannot possibly add everybody to the class at this point yet. But I'm going to keep doing this. So instead of making it, today, let's try, how about one more day?
Good.
So you guys can do it? One more day? All right, so that's one more day. All right, there are several important stuff that we have to talk about today. One is we have our first homework assignment, even before we even talk about programming concepts and whatnot. This one is really low in point values. In other words, it's 5 points. All the homework assignments will add up to maybe 600 or 700 points or so, and that is only 20% of your final grade. So in other words, this in terms of percentage of your final grade is tiny. But it is important that you do it so that I can make sure that you know how to do your homework after this. So let's go ahead and take a look at the homework. Oh, by the way, how do I find my homework assignments in Moodle in this class? Well, it depends. There are at least 4 ways to do it, so it's all up to you to decide which way works best for you. Is there an empty chair or somewhere so that you can sit down to? There's one folding one. So you can pull that one up here and then sit down here. All right. So let's go ahead and count the number of ways to find your homework assignment. Personally, for me, I like this upcoming events. Upcoming events will basically show you stuff that is upcoming within the next 2 weeks or so. Okay, so if I have an examination scheduled, it will show up here. If I have homework assignments scheduled, it will show up here. So that's the first place I would look, is the upcoming events. Unfortunately, the choice activity, the acknowledgement of the syllabus is not, does not show up automatically. So that one does not pop up here. But homework assignments do. So that's the first place. The second place is go to activities and look under assignments. Okay, so that's the second way to do it. The third way is to go to the current topic. I forgot to highlight the current topic. So now it's highlighted. If you see this little icon here, it's a hand holding a piece of paper. That's the icon of homework assignments. So you can find your homework assignments that way as well. So there are 3 ways to find your homework assignments at this point. Any other questions about finding your homework assignments? And the fourth one is I will talk about it in the class. Okay. I always, introduce the homework assignments because many times the homework assignments will involve topics that I have not talked about yet. And I will start to talk about it in the same lecture. I find that that's a very good way to motivate people to pay attention in class, because the assignment is going to use the same concepts as what I will be talking about. And some people can even ask questions in the class and basically associate the homework assignment and the topics that I'm talking about at the same time. So that really is effective learning. Basically, those students will be they will be studying and actually doing the homework at the same time. Okay. Any questions at this point about homework assignments, how to find them? Nope. Okay. So what I'll do next is I will switch to a student role so that I will see exactly what you guys will be seeing, so that I can actually do the homework assignment and turn it in. Is there another chair? No? You probably have to sit on the floor. Alright. Alright, so I am seeing what you will be seeing too. I will just click get LibreOffice as a homework assignment. And the due date is always stated clearly here. In this case, I give you an entire week to do this. Let me see how many people have a laptop today. 1, 2, 3, 4. Okay, so I'm expecting about 4, submissions by the end of this lecture.
You better get on it right now, then.
Yeah, exactly. You can actually access it right now. All right, so I'll go ahead and read the description of the homework assignment, and you should do the same thing. It's very, very generic. Almost every assignment in this class will be kind of like this. You have to download the file, open it with LibreOffice Calc, make some changes to the document, save it, and then turn it in by uploading it, using this interface. I will go through the entire process in this class so that you know what you're supposed to do with this homework assignment. There's no programming concept involved at all. This is all strictly clerical, okay? To make sure that you can get OpenOffice or LibreOffice installed, you know how to use it, you can follow the procedures, you know how to turn in your homework assignments. That's all that is to it. All right. So according to this, you're supposed to right-click and download this file. If you click it, it will still open, but it may open in a read-only manner, which means you cannot make changes until you click, File, Save As, then you can make changes. So I think it is better or easier for people to just right-click and download it this way. When you download it, make sure where you download the file to. I think most people in a class like this, know where to find the files they have just downloaded. So are there any questions, any issues with that? No? Okay. Most browsers will automatically put it under the downloads folder. But I think in some browsers you can also change it and say ask me every time, so that you can change the location where you want to save the file every single time you right click and save as. So I'll go ahead and save the file first. I can open it inside Google Chrome, but this is only because it's Google Chrome. Your browser may or may not give you a way to open the file conveniently like this. So the really foolproof way to do it is to open up LibreOffice, go back to that location, and then open the file. That cannot go wrong. Okay. I'm just going to cancel this. I don't need to recover these files. There we go. So now we have LibreOffice. Go to File and click Open. Go to the folder where I just downloaded the file, which is downloads in my case, and then go to the homework assignment. This is called Get Calc, so it's right here. Click Open, and this is your homework assignment. Let me crank up the magnification here. That's your homework assignment. Your homework assignment is one, you have to install OpenOffice or LibreOffice. It can be a permanent install on your internal hard drive. It can be a portable installation like what we talked about the other day. So you can take your thumb drive and take OpenOffice with you anywhere you go. It doesn't matter, okay? You can run Mac OS X. LibreOffice is available. You can run Linux. LibreOffice is available. Windows, not a problem. So most modern operating systems should be fine. All right. So I'll go ahead and answer these questions. Did you install LibreOffice? Yes. Did you download this file from the assignment link? Yes. Did you open this document using Calc? Yes. Because someone, I don't know who, but someone is going to use Excel to open this file, and by the time that person answers this question, that person should stop right away, close Excel, and then use OpenOffice Calc to open the document instead. Yes? Okay.
I know what Calc is.
Okay. The Calc is the name of the spreadsheet program in LibreOffice. Basically, Calc is the same as Excel. Okay, did you customize LibreOffice with your own name? Now, this part is also very important because I will check whether the document has your name on it. To customize LibreOffice for that purpose, you go to Tools, and then you go to Options, and the first item, which is User Data, will let you enter all that information. All I really care is your first name and last name. So in this case, I would type my first name and last name. The initials is automatic. Once you type in your first name and last name, the initials will be there automatically. I click OK. So that part is done as well. Okay. Remember to save this document before uploading it. Okay, I'll go ahead and File, Save. Make sure I save the file first. Now, personally, I would even close the document before I upload it, just in case I make a mistake somewhere or I forget about saving the file. Because once you close it, if you forget to save it first, LibreOffice will remind you that this file has been updated, but you have not saved the changes. So I get back to this part here. I go to the bottom part of this page, click Choose File, go to the folder where the file is located, open that file, and in Google Chrome it shows it like this. I'm not sure what it looks like in Firefox or in Internet Explorer, but this is what it looks like in Google Chrome. And then I click Upload this file. Remember to click Upload this file because otherwise the upload is not done yet. You have just chosen which file to upload, but you have not actually uploaded the file yet. You should see this screen before you feel, okay, I have just turned in my homework assignment. Okay? And then you could continue, and it's all done. Now, not only does it confirm that it has accepted your submission, it even gives you a link so that you can download your own file back again in case you want to double check, oh, what did I just upload? Did I answer yes to all those questions? Okay, you can download the file back to make sure that you uploaded the correct version of the file. Let's just, yes, go ahead.
Is all of this pretty much the same on OpenOffice?
It is the same as OpenOffice. LibreOffice is basically the new name of OpenOffice because it's no longer an Oracle product. Yep.
Do you know if this program has online storage to where you don't have to save the documents to your...
You can use
storage?
Moodle as your online storage.
Okay.
Because you can re-download this file, so if we're actually doing a homework assignment and you're only halfway done, upload it anyway. Because you can always download it back so that you can change it and then re-upload it later on. Okay? I have chosen to make it so that you can upload your submission as many times as you want to, as long as it is before the due date. So if you upload the file and then later on you talk to another student, the student reminded you, oh, did you do it in OpenOffice or did you do it in Excel? Oh man, I opened it in Excel. I didn't remember that I have to use OpenOffice. It's no big deal. You just have to re-upload it once you're done with using OpenOffice to open the document. Okay. I also made Moodle so that it does not accept late submissions. Okay. So after 10:30 on the 26th of this month, PST, Pacific Standard Time. Actually, it's daylight saving time. So it's PDT, local time. How about that? Because somebody's going to argue and say, I didn't know you mean Pacific time. I thought you mentioned, I thought you were using some other time, and I thought that I still have some more time left. So, let's make sure that it is local Sacramento time. So after this time, Moodle will close the interface, and this option here to choose and also upload the file will no longer appear. So make sure you do it, before the due date of the homework assignment. Any questions so far?
Nope, done.
Yep.
In Calc, each went into tools to change the name. I'm sorry, I was writing when you did that, so I didn't see.
Oh,
the
okay.
slide.
Let's do it again.
If you're in OSM, it's preferences instead of tools.
Oh, is it? Oh, okay.
Yeah, just heads up. Anyway, else it's using a Mac. Probably the only one.
Yeah, probably the one.
Mac users.
What can I say? I'm just a hipster when it comes to computers.
Well, the interesting thing is, the choice of operating system has very little bearing at this point, or it will have a decreasing importance when you're using a computer these days. Why do you guys think that I said that?
Because everything's going to Java and whatnot.
Everything is going to the cloud.
Yeah.
So all you need is a browser. Okay.
That's what I was going to ask. I thought that Google Docs was based on a lot of the same code that.
I don't know the code base of Google Docs. I don't think it is the same as LibreOffice. Yeah, I think it's Google's own stuff. Okay. All right. So that's your homework assignment. Any questions about it? No questions? You have a whole week to do this, as in 168 hours. That's a lot of time. Okay, 168 minus 18 minutes.
I don't know. That's not enough time.
I think we need more. Maybe another week.
I don't know. I don't think I can answer 4 questions in that amount of time.
Yes, 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 yes. All right. Okay, another thing I want to show you guys is how to find the video recording from a previous class. Okay, that can be handy in case, okay, let's just say that someone forgot how to do the homework assignment, or what to turn in and stuff like that. All you have to do is go to YouTube and enter the date of that particular lecture. So in this case, it's the 17th because we met on Tuesday. So you type 2012, 01 for January, 17 for the day of month. The class is cisp300, and it doesn't find it.
What's your username on YouTube? Can't you just search by that?
Yeah, you can look at my channel too. If you subscribe to the channel, it's actually easier.
Okay.
Todd.
Okay, so let's see here. Where do you find the channel?
It's upper left-hand corner of the video.
Right there.
Oh, that's actually under my own name.
No, try next to subscribe.
Go down.
Yeah, but that's under my own name. Some props. I think this is the proper one. There we go. So you just say subscribe, and that's it. So once you subscribe to it, you will also get notifications when a new recording is available.
Isn't that cisp370?
Sorry?
The bottom it says cisp370.
Yeah, because we have different recordings for different classes, so that's why when you subscribe to the channel, you still have to filter out the ones that are irrelevant to this class, and that's why you have to look for cisp300, because on the same day there may be multiple classes that is recorded and uploaded, so you have to look for this specific class. Okay? Any questions? If you look under videos, it will be sorted by time, in a reverse order. So, oh, okay, I know why, because I made a mistake here. Look at this. Wrong date. That's why. So, my bad. But once you look at the channel, it's easy to locate it. I mean, even if I have a typo. You're more than welcome to watch the other video clips too. These 4 are about using Debian Live, which is the environment that I'm using right now. So if anyone is interested in running Linux as a live distribution in a virtual machine, those 4 video clips, can be helpful. But obviously, you don't have to do it. These are from the cisp300 class, which is a Visual Basic class. It can come in handy. You won't get credit, you won't get a grade, you won't get credit by watching the video. But if you're curious about Visual Basic programming, go ahead and watch it. And learn about Visual Basic programming on the side. It's actually not a bad idea if you have never written a program before. Taking this class and VB at the same time is actually a very good combo, because one class is kind of more dry, this class is dry and more theoretical. You have to do everything by hand. The other class is very interactive. Okay, you have to design forms with buttons and text boxes, and you actually write code in the other class. Yep.
I have a question. Why not have us do everything in Bash? I noticed like in your examples that you have online, because I've read ahead a little bit, like everything seems like stuff that you could do just in Bash so far. Why not just have us write Bash scripts to do these algorithms?
Because I don't want any syntax in this class. I don't want people to have to worry about syntax.
Okay.
Bash has one of the worst syntax in terms of programming,
Okay.
at least for beginners. Once you know programming, everything actually makes sense. Pro is another example. The notation used in Pro is very foreign and very unfriendly to beginners. But once you understand programming and understand what Pro is really for, it all makes sense. But in this class, since it's a beginning class, I want people not to have to worry about syntax and just focus on the concepts.
Okay.
But that's a good question. All right. So are there any questions about finding video screen recordings for this class? Questions? Okay. It can come in handy, especially when we get to more complicated concepts. So we were still talking about algorithms and developers. So we'll focus on developers because this class talks about programming, which is the primary job responsibility of developers or programmers, or software engineers, as we call them. The major challenges in terms of program development has several things. One is programming language syntax. That's basically the grammar of writing programs. Where do you put a comma? Where do you put semicolons? Should you use the round parentheses or the square brackets? Those are all syntax of a programming language. In English, I make grammar mistakes all day long, okay? But yet most of you can still understand at least 95% of what I'm talking about. Why is that the case? If I say, yesterday I picked up my kids instead of picked up my kids, you still understand what I really mean. Why is that?
It doesn't require you to be exactly precise.
Exactly. Okay, people are much more flexible. If I say yesterday, then you already understand it is in the past. So even if I use the wrong tense, in the verb, it's still okay. I mean, you still get the meaning of the sentence. But computers are far more rigid. Okay, if you make a simple mistake, use a semicolon instead of a comma, it won't work. Okay, it's not going to work anymore. So the first challenge of a programmer is really to learn the syntax of a programming language. Some programming languages are easier to learn, some are harder to learn. It also depends on the environment. Okay, some environments makes it easier. But I would say that part is just a matter of time. Okay, if you spend enough time with a programming language, you can master it. It's not a problem. The second part is programming logic. Okay? Now, when we talk about programming logic, we are talking about logic at a very detailed level. It's not just a high-level description like the Wells Fargo Bank executive may say, if anyone failed to log in 5 times consecutively, lock out that particular account. That's overall logic. But when you need to write a program to implement that feature, you need a lot more details than just that one little sentence. Is that okay so far? Programmers have to focus on a lot of minuscule details and also logic down to that level. And a very common comment from programmers is a systems analyst already specify how the system is supposed to perform, so how come we still need programmers to finish the coding and not have the systems analyst to do the coding as well? Well, the answer is really quite simple, because last time we talked about how the engineer has to come up with the blueprint of a house. So technically speaking, the engineer knows exactly where each faucet is supposed to go, where each wall switch is supposed to go, and so on and so forth. So technically speaking, the engineer can do it. But when you're actually installing a faucet or a light switch and stuff like that, there's a lot of detail that goes into the installation itself. Not just the location or the size of the pipe and stuff like that. It's the procedure of how to get that thing installed. It's the same thing here. The programmer has to worry about the details of installing the faucet, the light switch, and so on and so forth. But the systems analyst only has to specify the location, the size of the wire or the pipe, and so on and so forth, just overall specifications. Now, because of all this detail-oriented work, programming requires extended periods of highly focused attention to logic, details, logic, but you need to be very focused. A systems analyst has to answer phone calls all day long, because remember, a systems analyst is kind of like an architect too. An architect has to talk to the client, has to go to meetings, go to job sites, and so on and so forth. That's very distracting to the task of actually writing a program. So that's why a systems analyst most of the time cannot function also as a programmer, even though that person may have the expertise to do so. When a programmer is writing a program, the attention is more like a laser beam, okay? So only one dot is illuminated, but it's really, really bright. A systems analyst is more like a flashlight, okay? It's general purpose. It shines a general area, okay? A secretary, an administrative assistant, is more like a normal lamp, okay? You turn on the light and everything is illuminated. I personally cannot be an administrative assistant. I think that's a really tough job because it has a lot of multitasking involved. You have to answer the phone, type letters, and you have a lot of things going on at the same time. I cannot keep track of all those different things that are going on at the same time. Programmers typically have a really focused mind, but they can only keep track of one thing at a time. The most challenging part of becoming a developer is debugging. Debugging refers to the process to remove faulty logic from a program. Okay? Why do you think that part is important? Don't people write perfect code the first time all the time?
Of course, right?
Well, if that were the case, we wouldn't have patches, right? Have you applied your weekly patch today? Okay, well, it's not Tuesday, so there's no patch from Microsoft. But everything has patches. Adobe Acrobat Reader has patches. In fact, it is one of the more it's one of the major security concerns is actually not Windows itself, but the programs that runs on top of Windows. Because a lot of times if you have a security flaw in Acrobat Reader, and someone crafts a PDF document to exploit that security flaw, they can get into your system through a PDF document. Many years, well, not too many, maybe a few years ago, I think people found a security flaw in the graphics or the bitmap rendering library in Microsoft Windows. Okay, in other words, when you display a JPEG or a GIF file in Windows, it can potentially break the system. Someone can handcraft a GIF or a JPEG file to include malicious code so that when your browser, Internet Explorer, brings up that image, the security flaw will be exploited and someone can get into your system through your browser displaying an image. Now that is a very bad thing to happen because as a hacker, go ahead.
Just a thumbnail image?
Any image.
Well, you can get an image that's the size of a pixel, so you'd never even know it's there.
Exactly.
You never see it with the naked eye.
Yeah, but the best way to spread a virus in that case is to post it as an eBay item. I'm selling this really hot item, iPad 2 or something that people really look for, and advertise it for a very low price so that people go, oh, this is a good price for iPad 2. Click. System infected. You don't even have to go to very questionable websites. Just eBay. Okay, any place where people can post, their own content can potentially have, stuff like that. Now, obviously, Microsoft has since, fixed that security bug, but it did exist for a long time before people found out, that particular security hole. Okay, and all those security holes actually all go back to debugging. They're flaws when people write their programs. They forget about certain things, okay, certain details. They forget to check certain things, and that's why we have all these security issues. Now, software development is an iterative or repetitive process that requires thinking. How am I going to do this? Coding, actually writing the code in C, C++, Java, or any programming language, testing it, and after testing, it goes to debugging. In other words, when you test the software, you are comparing the behavior of the program to the specifications. If it does not perform as specified, it is flawed. Now, it can be a flaw in the specification. In other words, whoever wrote the specification did it wrong. But most of the time, it is the implementation that is incorrect. Then you have to go back to debugging and fix the bug or fix the defect. The task of finding out why a program is not working requires a lot of focus as well. It's basically a jigsaw puzzle, okay? Because all you can do, all you start with, is the symptom of the problem. The program is not working the way it's supposed to. It did this instead of that. That's the symptom. That's your starting point. But then you have to look into the source code to find out why it is doing that. And trust me, it's not that easy to find out why your program is not behaving correctly, especially when your program is large and also most of it is not written by you. When you go out and become a software engineer or a developer, most of the time you'll be fixing somebody else's code. So what you need in that case is a very analytical mind. In other words, you really have to sit down and think, okay, if it can get to this point of this program incorrectly, it must have these conditions being true. So you have to be really, really analytical. And you cannot, people cannot have tempers because the program is not working. Okay, as a software engineer or a programmer, a short fuse is definitely not an advantage. I guess in some other, occupations, a short fuse may not be so bad. But in programming, it's definitely counterproductive. I have not known a single programmer who has a short fuse, especially when they're working. Okay. But in terms of hardware engineering or electrical engineers, I have known quite a few people with short fuses. One guy was doing some CAD design and then the computer-aided design. So he was doing some CAD stuff, and the software didn't do what he wanted the software to do. So he got so frustrated that he threw the mouse across the room. Now, this is not a cord. It was not designed as a cordless mouse, but it became one. And the funny part is, it was reported to HR, Human Resources. So the lady who was in charge of HR at the time wrote a statement and made the electrical engineer sign the statement to say that I will not throw a mouse across the room again. It was just funny. Now, this debugging task is what separates developers from non-developers. Writing programs is easy. Okay, there are different levels of writing programs. This is 2012, so 12 years ago. Okay, many of you are still really young, so you may not even know about what year 2000 or 1999 is about. What is so special from the perspective? Sorry.
Y2K bug. The Y2K bug.
The Y2K bug is one, but it was also the .com boom, during that time. From 1998 to early 2000, was known as the dot-com boom, because the internet became affordable and very accessible by everybody. So all of these venture capitalists decided, hey, we can get in at this point, make a product or a service that has never been done before, make gobs of money, and get a lot out of this internet business. So they basically started up a lot of startup companies in the Bay Area, and they quickly exhausted the local supply of developers, programmers, and software engineers. Okay, even though the Silicon Valley has a lot of those people, they just soak it up in no time. And then they have to go to colleges and universities to recruit students, graduate students first, and then they move to undergraduate students. Okay, if you have a good grade in programming classes, you get your job. And I'm not talking about just a job you're making $1,500 a month or something like that. They're more than willing to pay $4,000 for undergraduate students from a university doing coding, okay, or more, depending on the company. And they quickly exhausted that as well. Okay, so between UC Berkeley, San Jose State, and all the surrounding universities, they could not produce enough undergraduate students who are still in school to fill these jobs. So they move all the way to high schools. Okay, high schools. So they go to high schools to recruit students who know something about web scripting. Okay. Now, when I say know something about web scripting, the standard got down to, oh, I have just read how to do web scripting, for dummies. It comes with a CD. I can copy and paste code, and I know the code well enough to customize it for your application. You're hired. Okay. So that's why I want to mention it, because those people would not be able to debug the code. They can copy, paste, and modify the code, but they would not be able to diagnose problems. If the code has a problem, they would not be able to go back there and find out, okay, how come this stuff is not working? And that is also why we have a lot of security issues with web scripts. A lot of times if a website is broken into, it's not broken into through the operating system. It's not broken into through the web server. It's usually broken into through the HTTP interface. In other words, this stuff here that you see, you can craft it on certain websites to make the website do things that it is not supposed to do. And it all came from 1999 with all these people who have just read a book on web scripting and decided to become a web developer. All right, we'll get back to this later. Now, after you write a program, after the developer writes a program, somebody has to test the software. A test engineer is basically a job title, a person whose only job is to check whether the information system or any type of system behaves the same way as it is specified. It can be, now when we talk about a system, we can be talking about Wells Fargo's online system. Okay, that's a classic information system. We can be talking about your iPhone app. We can be talking about the vehicle stability control of your car. Okay, it doesn't matter. Somebody has to check and make sure the system performs as specified. Who is going to do it? In other words, if you're building a house, would you ask the architect to check and sign a paper and say the house is built exactly the way it is specified? Now, how about the engineer? He has all the scientific, and engineering knowledge. No, probably not that person. How about the contractor, the guy who actually puts in everything? No, the answer is no, not because that person is dishonest or anything. A general contractor can be 100% honest and miss a few things. Okay, it happens. Okay, mistake happens all the time. But if you ask the same person who forgot to install a light switch in the house to check whether the light switches are all installed correctly, that person will probably forget about that light switch again. So that's why you don't want to use the same person to check the system. Instead, you have to hire another person, to do a house inspection, give that person the blueprint of the house, and that person, without any prior knowledge, without actually building the house in the process, will have to go and check the light switches, the faucets are all installed correctly. So a test engineer typically is not a part of the development team and only has access to the specifications and test everything according to the specifications. Right. So now we move on to the term algorithms. I have just talked about the different types of people that a developer has to work with. So at an earlier stage, you have the systems analyst, which produces the system specification. At a later stage, there's the test engineer, and all those people have to work with developers. An algorithm is basically a method to complete a particular task. In other words, it's just a fancy word for method, a way to do something. That's about it. But it is also a little bit more specific. An algorithm has to be precise. Now, what I mean by precise is it cannot be ambiguous. In other words, there cannot be two ways to interpret the same statement when you specify an algorithm. Okay? An algorithm is also specific. In other words, a particular algorithm solves a particular problem. Okay? Now, most universities, and many of you are moving on to four-year universities, they have an upper division course called algorithm analysis, or sometimes it's reversed called the analysis of algorithms. That's pretty much a high-level math class. They don't do programming. Your job is to prove certain properties of an algorithm. Now, what kind of properties are we talking about? One, will the algorithm complete? Okay, you give a problem to the algorithm. Is it going to end at some point? Seems like pretty stupid questions, but those are valid questions. Two, how long would it take for any computer to solve a problem? Okay, sounds like a stupid question, but that's actually very important. Okay, it's a very important question. We'll get to those concepts just a little bit in this class, so that you have some exposure to those concepts. In this class, just unlike many other programming classes, we don't write any actual program code. We don't write code in C, C++, Java, PHP, or any of the popular programming languages. Instead, we use some really weird-looking pseudocode. Pseudocode is derived by two words. Pseudo means not true, and code means program code or program, the actual logic in a program. It seems like pseudocode has no use at all, because after all, when we write code, it is intended for a computer to execute. So why would we spend time making up a quote-unquote programming language that is not intended for computers?
Maybe it could be applied to actual language.
Not exactly. Go ahead.
To communicate with other programmers who understand different languages and frameworks.
Exactly, so that we don't have to deal with the specific syntax of specific programming languages and focus on just the concepts. Okay, so we can focus on just the logic. Some old school programming paradigms require students to write programs in pseudocode before the pseudocode is translated into C and C++ and other programming languages. Just because in pseudocode, your mind can focus on just the logic and not the placement of parentheses, commas, semicolons, and so on and so forth. Okay. In this class, the pseudocode that I choose to use in this class is very verbose. In other words, it's longer, it's much longer than it has to be, but it is much more clear. It's clearer that way. And that's why I chose to use pseudocode in this class, so that we can make it very clear for beginning programmers. Now, pseudocode usually has a few attributes. The first one is it is precise. There are no international standard for pseudocode, unlike C, because when you look at the C and C++ programming languages, there's the ISO, the International Standard Organization. They publish a standard and say that all C compilers should behave this way. Okay. There's also the ANSI organization, the American National Standard Institute, something like that.
Sounds good.
Which also publishes their own standard for the C and C++ programming language. But there's no such thing for pseudocode. Pseudocode is really kind of fuzzy. There's no global standardization. But most published books and journals use a widely accepted form that is precise. In other words, it is not, there's no ambiguation. Okay? If a line says blah, 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 there's only one way to interpret that line. It is concise, which is kind of opposite to what we will be using in this class, because we're going to use a fairly verbose format in this class, and also flexible at the same time. If anyone wants an example of pseudocode, all you have to do, we're lucky that Wikipedia is not blacking out anymore, and just look for some algorithms. I'll look for some really generic one, like binary search, okay? Because we will deal with binary search anyway later on. So we'll just go ahead and use this as an example. I'm not expecting anyone to understand the algorithm as specified here. Now this one is in Pascal. I'm not sure whether they have it in pseudocode. That's not pseudocode, that's actually, is it Python? This is Python. Let me see if I can find something that has pseudocode. Ah, there we go, pseudocode. So that means, what that means is, when you're done with this class, or when you become a programmer, this, even though it's not a particular programming language, it will still make sense to you. You can understand exactly the logic it is trying to convey with no ambiguation. Okay? And that's pseudocode. That's one form of pseudocode, not the one that we are using in this class. It's just another form of pseudocode. But programmers can have to be able to understand different types of pseudocode. Okay. Now pseudocode is also what we call structured. Okay. Well, that term really doesn't mean a whole lot of stuff to most people. What do you mean by structured? I can give you one single example, and all of you will go like, oh, so that is structured. Okay, let's just say that you just went to Fry's and buy your 2 terabyte hard drive. How much is a 2 terabyte hard drive these days? $100, 120, something like that. And the file system that you choose to use says you cannot have subfolders. The entire 2 terabyte hard drive only has the root folder. C:\/ is the only place you can put files. That is unstructured. Okay? Now, most file systems that make sense is structured. Why is it structured? Let's take a look. So let me start up my file manager here. It doesn't matter what file manager you use, I can still illustrate the same concept. Okay, I'll start with the root of the entire system. You see all those folders? That's an organizational unit. Okay, it can impose structures because now my entire drive, which is not really the case in Linux, but let's just say that this is my entire drive. My entire drive is first broken up into many folders. One of these is called home, and I can still put files in the root folder, the top level folder. But inside the home folder, I can have subfolders. Inside each subfolder, I can have other subfolders, and inside each one of these subfolders, I can have even more subfolders. That is structured. Okay, if your drive or if your file system cannot support subfolders, you have to put everything under C:\/ that is unstructured. Why is structure good?
Allows for organization.
Allow for organization, but without organization, what is so bad about unorganizing?
You can't find anything.
chaos. You cannot find anything. Very good.
You have a mile wide and an inch deep directory.
Yeah.
Yeah.
You cannot find things easily because your mind can only keep track of several items at the same time. Now this kind of goes back to our discussion with psychology, because there's a certain number of items we can keep track of, at any particular time. Does anyone know what is the current published number of the number of things that we can keep track of? Yep.
7.
About 7. So it's about the same as when I took my psychology class. Some people can expand that to maybe 20. Okay. Some people, like myself, has to shrink that number to 3. Okay. And Rain Man probably is up to 100. The movie Rain Man
Yeah.
with Dustin Hoffman. It's a long time ago. He was still very young at the time.
It was a good movie.
It was a good movie. But he can keep track of a lot of things at the same time. But nonetheless, it is still limited. Okay? And because of that, we have structure. Another example I can show you about structure, and I will do this again later on, is this. Let's go to Google Maps. Okay? I don't see ARC here. I don't see room 121 of ARC on this map. Now we know that the area covers this portion of the country, but I don't see ARC or room 121. Why not?
Because you're too high a level.
This is a high level map and this is a low level detail. Okay, room 121 on campus is a low level detail. Well, is it because of physically we just cannot display that text?
Yeah.
Well, that's one reason. Okay, so let's just imagine that this is a magical screen and that's a magical projector. It is capable of infinite resolution. In other words, we can have an infinite number of dots on the screen. So in that case, I can actually put room 121 of ARC on this map. The question now is, can you find it?
No.
Because along with room 121 of ARC will be room 122 of ARC and so on. So once again, without structure, even if you have a magical map that has infinite resolution, without structure, you cannot find anything. Okay, because we just cannot process all the information all at the same time. So we'll come back to this structured deal later on. And for now, we'll move on and talk about conciseness. Concise means density, basically. How much logic can you express on a single printed page? Basically, that's what it means. This is where I can answer questions about but Tag, why don't you talk about flowcharts, graphical ways to represent logic? Isn't that a whole lot easier to understand? Initially, yes. Okay, graphical means to display logic is a lot easier to understand. However, it has one major drawback. As you start to add more and more logic, it becomes harder and harder to update the diagrams. And the diagrams will become bigger and bigger. Okay, so you can't really fit a lot of logic on a single page, a printed page, when you use flowcharts. But Tag, if that's the case, how come we use flowcharts all the time, when we want to display logic, especially to managers and executives and stuff like that? Well, that's because they don't have to deal with low-level logic and all the details that developers have to deal with. Okay? And pseudocode is very, very dense. In other words, I would even argue that pseudocode can be more concise than actual programming languages. There are certain things that we can express. I'm not going to expect anyone to be able to understand this. I can say in pseudocode, I can say for each E as an element of the set S, do the following, blah, 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 blah. Okay? That's a really high-level description. It can be in a pseudocode specification, but the implementation of this, depending on the programming language, can span across many, many more lines than in pseudocode form. Okay? So that's why I said pseudocode can be more concise than actual programming languages. It's just that in this class, I chose a form that is easy to understand as opposed to being concise. How many people have some idea of what this actually means? Okay, very good.
Which language?
Mathematically.
In which language?
It's somewhat mathematical, but it also has a programming aspect to it. Because in mathematics, you can say E is an element of a particular set, S in this case. But I also put this around it, which means it is now procedural. Okay, I'm taking each element, I'm looking at each element in the set, and I'm performing this operation to each element, one by one, sequentially. All right. Pseudocode is also language independent. But tag, what do you mean by language independent? That's an English word, that's an English word, that's an English word. Well, even though we do use borrow English words in pseudocode, it's very limited. In other words, most people with a foreign mother tongue or native language should be able to learn pseudocode in no time, because we use about 20 at the most English words in pseudocode. So it's not a big deal. It's language independent. And the last part is the most important part. The syntax is very flexible. As long as the other person, the person who's reading your pseudocode, understand what you mean, it is okay. It's that flexible. So now we are done with that module, and it's time to move on to some real stuff. Okay, now we move into actual programming in topic 2. So let me change the highlight so that I can put the highlight on topic 2. I have to turn on editing first. And put this light bulb here. All right. So now that we have talked about what an algorithm is and general ideas of pseudocode, let's actually go into those concepts and talk about variables, expressions, and sequences. Very basic building blocks of writing pseudocode programs. And I'm going to have to change this example after a while, because this is really archaic. People don't do this anymore. Yep.
When you talk about pseudocode and communicating between one another, isn't there room for interpretation or misinterpretation?
That's one thing about pseudocode is the representation cannot have any ambiguation. In other words, if this is read by another programmer, it can only mean one thing. There's no other way to interpret this code here.
So if you sent me something and I wrote it incorrectly, it's because you didn't communicate properly, or because I didn't understand it properly?
In that case, if that can happen, it is because the pseudocode that we chose to use is not precise enough. So it would not be a good choice, in that case. Yep.
Is there like set notation in math, or like
Yes, pseudocode actually programming, computer science and programming was originally a branch of mathematics. And that's why, in some of the programming languages, especially the earlier ones, like Pascal and some of the earlier programming languages, they borrow a lot of concepts, a lot of words, a lot of operations from mathematics.
Okay.
And I will also talk about that a little bit in this class too. Later on, we'll talk about the concept of is it required that a programmer must have a math degree first? Okay, so that's basically a question, because in many universities, okay, the computer science department has 3 ways of spinning off and becoming its own department. Okay, the first way is from math. Okay, in other words, some universities have their computer science department originally as a spin-off from the math department. It can come from engineering, computer or electrical engineering to be more specific, and that's the case at UC Davis. Coming from math, I can come up with one example: San Francisco State University. Okay, so in that university, computer science faculty was original. They were all originally math faculty. Maybe not at this point because they have changed a lot of people since I took classes over there. At UC Davis, computer science was originally a division, a branch in the electrical engineering department. And then here at AR, computer science is a spin-off from business. Now that seems really odd, doesn't it? Well, it's a longer path, but it actually still makes sense. Because business has business applications. Okay, so when you teach business, you have to teach people how to use Excel, Word, and so on. So before long, Word and Excel can be customized using VBA, a Visual Basic for Application. Not heavy-duty programming, but nonetheless, we are moving a little bit out of application and into programming. So from there, it makes another jump. From VBA, you can go into VB, Visual Basic. So it's not even tied into an application anymore. It is completely standalone now. Okay, and that's why computer science can also be a spin-off from a business division, and mostly at community colleges in that case. Because it starts from very applied, very application-oriented, and gradually move to the computer science side. Okay, so here we have some logic that I want to express. Okay, so this is back maybe 30 years ago. People used to do this. They get their credit card bill through the mail. How many people still have credit card bills sent through mail? Okay.
Killing all those trees.
I
said you're killing a lot of trees. Paperless.
Go paperless.
It's more secure to do it that way. It's more secure to do it that way.
It's actually more secure through electronic. The electronic form is more secure.
Yeah, but then you could also say you can get a virus on your computer where they can do.
Yep, it's the question of how well do you manage your computer.
Yeah.
Yep.
You don't manage your computer very well, do you? Not borrowing your computer.
Well, it also depends on who else is using your computer.
Oh yeah.
Yeah, that has a lot of bearing to the overall security of a computer. Most computers are not broken into by active hacking. In other words, it's not like you just power up your computer, hook up to the network, someone finds your computer and breaks into your computer. It is possible, but that's not the usual case. The usual case is the malicious software is invited in because somebody click a link, somebody click yes, when the browser asks, do you want to install blah, 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 and so on. So most of the time it is invited, and that's a human problem, not a technology problem. All right, so let's just say this is the logic I want to express. The first thing I would do once I receive my credit card bill is, okay, I owe the credit card company this much money. And instead of saying this much money, I'll just call it X money, X amount. Is that okay so far? Okay. So whatever the X amount is, assuming I have enough money in my bank, I want to pay off my credit card bill as much as possible, as soon as possible. So I would write a check of that much money, make it payable to the credit card company, put it inside a little envelope, and send it out. After that, I want to keep track of how much money I still have left in my bank, because remember, this is before online banking. So I kind of have to keep track of how much money I have in the bank. So I would deduct the same amount of money, which is my balance of the previous month, from available funds of my checking account. And if I want to keep track of how much money I have spent through a particular credit card, I can add that to the annual sum of that particular credit card. Is that okay so far? Does everybody understand what I want to do? The operations that I want to perform. Okay. Now let's just use this example and see how many variables we have already talked about. The first one, okay, well before we talk about which variables, let's talk about what a variable is. A variable has a name. Now a name is very important. A lot of things in computer science, in programming, has a name. But they don't call it a name. They use obscure stuff, obscure words to mean a name, like identifier. Okay, what a name is really just a way so that you can tell this apart from that. That's all there is to it. Okay, variables have names because you want to differentiate this variable from every other variable, all the other variables that you use in a program. That's why you need a unique name for every variable. A variable also has a type, which basically determines what you can and cannot do with the content of a variable. Let's not worry too much about types at this point. The more important part is a variable also has a value, which is also called a state of the variable. You can imagine a coffee mug is a variable, okay? But on the outside of the variable, on the outside of the coffee mug, you have to give it a name, so that when you open up the cupboard, you can say that particular coffee mug, I want to use that coffee mug and not the other coffee mugs. So the name differentiates this coffee mug from all the other containers inside the cupboard. The content, or the level of content inside the coffee mug, is the value of this particular variable. It can change. You can pour more liquid into it so it is more filled up. You can also empty it so you can change it on the fly, and therefore the name variable, because it can change over time. Okay? Are there any general questions about variables? Just the concept. It has a name, it has a value, and the value can change over time. Okay. In the previous example, we have a few variables. X is a variable because the amount that I owe the credit card company changes from one month to another. Okay? And that's why it is a variable. But it does not change as we perform those specific steps. We have other variables. One, to keep track of available funds. It is a variable because before I pay my bills, it is a certain amount. After I pay my bills, it is lower. And therefore, it is changing, and it is a variable. We also have the total expense for a particular credit card. In this case, I'm assuming it's American Express. It is also a variable because before I pay the bill for this month for that particular credit card, it is lower. But as I pay that bill, it becomes a higher value. So those are all examples of variables. Are there any questions about what a variable is, what they are used for? They're used for storing information, data. Okay, in this case, numbers, numerical values. Okay, any questions at this point? Yep, go ahead.
Does it matter what the type is? Because you have type.
At this point, we don't pay too much attention to types. The type determines what you can and cannot do with the value of a variable. At this point, we are all dealing with numbers, so you can add, subtract, compare, multiply, divide, and so on and so forth. So we are not too concerned about the type yet. Later on, we'll introduce other things where it doesn't make sense to multiply, it doesn't make sense to divide. So at that point, it becomes important to talk about types. At this point, we will just say, well, we're all dealing with numbers here, so it's not important at this point. Before we move on in the notes, let me give you an example here, and then you guys can tell me what it means. Choose a larger font so that everybody can see it. What does that mean?
X equals 2.
X equals 2. Okay. Now it has 2. Aha. Now somebody is being more specific here. If you present this in a math class, if you present this to a math professor, the professor will look at this and say, oh, so you're telling me that X has a value of 2. It's a statement. You're stating X has a value of 2. It can also be a question. X equals 2 can either be true or false. Okay? In programming, in most programming languages, this means change the value of the variable X to 2. Now that is very different from the other two interpretations of exactly the same line. Let me say that again, because I think it can be confusing. The first interpretation is a statement. X has a value of 2. X is 2. Okay, that's the first statement. The second interpretation is it's an expression. It's a true-false expression. Is it true or is it false that X equals 2? So that can either be true or false. The third interpretation is let's change the variable x to a value of 2. Yep.
It sounds like statement 1 and 3 are the same.
Nope, they're not the same. Let's look at another one here. Now this makes the change. You present this to a math professor. The math professor would just laugh at you. Okay? Why?
Because you said
X has no value yet.
Well, because even using the first and the second interpretation, it makes no sense. X is x plus 1. I don't think such an x exists. Okay? X equals x plus 1. Is it true or is it false? It's always false, right? Independent of the actual value of x, x equals x plus 1 has to be false. So your math professor, who will only use the first two interpretations, will just laugh at this and go, that's a senseless question. You present this to a programming instructor. The programming instructor says, oh, so you want to increase the value of x by 1. If it was 2 before, now it is 3. If it was 500 before, it is now 501. Because what it means is you interpret, or you examine, or you evaluate the right-hand side first. Whatever that becomes, you use that value to update the left-hand side. And that's why I don't use the equal symbol for that purpose in this class, because I don't want any ambiguation in my pseudocode. So instead of writing it this way, I write it like this. The less than and the dash means left arrow. Okay, it's indicating the direction where the information is flowing. So this makes it very, in my mind at least, it makes it very clear that we have to first evaluate the right-hand side using the current value of x. Okay, x has to have a current value of some kind. Can be 2, can be 500. It doesn't matter what it is. Take that value, add 1 to it. It becomes the right-hand side. Once you evaluate the right-hand side, use that value to update the left-hand side. Okay, this is called an assignment operation. Yep.
So for the pseudocode that we'll be using in this class, you want us to use less than dash.
Yes.
In lieu of that.
Or if you can type the left arrow symbol, is even better. For the most part in this class, you are not writing any code. Okay? I give you the pseudocode and I always use this representation to mean update the value of x so that it is 1 more than what it used to be. Okay? So remember, the order is evaluate the right-hand side, then update the left-hand side. Any questions about this part? Yep.
So it doesn't always flow right to left. It flows, for instance, from left to right. Just
In this case, the information is going from right to left.
okay, just particular.
Yes.
Okay.
And I always use a left arrow. I never write it. I don't use this representation. Okay? Even though logically it's just symmetric, I don't use it because programming languages, or most modern programming languages, only accept the variable to be changed on the left-hand side. So I'm preserving that part of a regular programming language, but I'm changing the symbol so that we can clearly differentiate, am I comparing or am I changing? That's the question. Because the other way in the program, in the context of a program, x equals 2, it means comparison. I'm comparing x to 2. I can only get one of 2 answers. It is true or it is false. Okay. Are there any questions about this assignment operator? Okay. Now, I have to tell you one thing way ahead of time, because this is only our second class in cisp300. Many of you are moving on to cisp360. So now the question is, if x equals, okay, if this really means this in programming, how are we going to express comparison? In C and C++ and any programming languages that are derived from those, from C, you use double equal to mean comparison. Okay? In other words, x equals 2 in C means change the value of x to 2. X equals 2 means compare the value of x to the value of 2 and tell me whether it is true or not. It is only different by one equal symbol. If you look at your program at a glance, using a relatively small font, most people cannot easily tell which one is which one. The problem is, in C and C++, those two operators can appear at exactly the same places. If you use the wrong one, your program will behave incorrectly. But visually, it's really hard to see. So keep that in mind when you write your C program because of that. Okay. Now we move on to expressions. We have just seen this. So in my original logic, what I can do now is I can say available funds is going to be updated. This is the left arrow symbol again. It means assignment. So what I will do is I will take the current value of available funds, take the value of X, do the subtraction. The difference will now be used to update available funds. Somebody's going to say, but that means we have to do this all over again because we just changed the value of available funds. That is not the case. Okay? Assignment operations are one shot, which means you evaluate the right-hand side, you update the left-hand side, you are done on that line, you move on. Are we doing okay so far? Okay. The next line is about the same, except I'm incrementing the value by X because I'm adding X to the AE total expense of the program. And this is a slide that talks about assignment operations in general. Every time you have an assignment operation, it must have 3 components. It must have a left-hand side. The left-hand side has to be a single variable that will be updated later. You need the left arrow symbol because that indicates this is an assignment operation. And then you need a right-hand side. The right-hand side can be just about anything. Anything that can give you a value can be the right-hand side. It can be another variable, can be the same variable in some sort of expression, can be a constant, can be anything. Anything that can give you a value to update the left-hand side can be the right-hand side. And here I talk about how the assignment operator, the left arrow symbol, is replaced by the equal symbol in most programming languages. So you have to be extra careful when you're programming in C and C++. Constant assignments. At the beginning of a year, I probably have to perform this operation because I have to forget the total expense from last year, reset it back to 0 so that I can count from 0 again at the beginning of a year. And 0 is a constant. It's really easy to understand what I need to do here. Self-referencing assignment is a little bit harder, but we just explained what it means. So in this case, we have AE total expense equals or gets AE total expense plus X because we just take the current value of AE total expense, add X to it, it becomes a sum. I use the sum to update AE total expense. So after this step is performed, that variable will be increased by X. So I have this example here. If AE total expense was 263 and X is 71, after this operation, AE total expense is going to have a value of 334. Now this is where things start to become a little bit more interesting, and also this is very specific to this class. We are running out of time, so I cannot talk about it now because it's a fairly long topic, and I do want to show you why we are using spreadsheets in this class. That is the reason. So read ahead of me again, okay? We are up to this point, so you definitely want to read ahead of me, which means cover variables, expressions, and sequences, and try to get into conditional statements. There's a homework assignment. For those of you who are in the class already, make sure you select the choice and say that you know where to find the syllabus in Moodle. Okay? All right. I forgot. I'll do it on Tuesday. I forgot. So I'll do that on next Tuesday.
Don't worry.
There's not no trees.
Go ahead.
How can I get the account in Moodle?